It's called Live Wire, and it's coming up with some wonderful guests. We have some people who are talking about some absolutely scientific, astronomical inventions that are really coming to fruition. They may have been science fiction in the past, but science fiction has a way of becoming reality, as you well know. Then I have a wonderful John Farias is going to play us a couple of songs on his steel-strung guitar, and we're going to have a really great show. It's called Live Wire, so stay tuned right on this channel, right here. Sit down, get something to write with, and enjoy yourself. Team Astro Aranie. We have today a filmmaker and a founder, Mr. Michael Remington, who is a founder of this organization, a co-founder, I suppose you would say.
Sure.
Right? And you, young man, are making a film about this idea. Is that correct?
Yes.
Great.
Started in 2006.
You did. And it's now made into a film, and it's coming up real soon.
There'll be a showing of it on Thursday. It's a 1-hour feature film. It'll be in collaboration with presentation by the AIAA, which is
IAAA, American Institute of Aeronautics and Astronautics.
He's touching on the theme of our talk.
That's right.
Which is something astronomical, right?
That's
Tell
it.
me, explain what the Mighty Tether is and a space elevator. What is it?
Well, Mighty Tether is the title of the film that was based on some of the work that we've been doing with the space elevator. And the basic concept is that if you actually had a cable that ran out into space, up through geosynchronous orbit, and stayed over one point on the Earth at all times, that is something you could climb up, either mechanically, most likely, and be able to start going into space, launching cargo for a very inexpensive cost.
Yeah.
That's the big push.
So
it could lower costs by almost a factor of 100.
how far up is that to put something in a geosynchronous orbit?
Well, most geosynchronous orbits are approximately 36,000 kilometers high above the Earth and in a circle. And so you could put a satellite anywhere on that circle that is 36,000 kilometers out from the very center of the Earth. And but with the space elevator, you actually have to have your center of mass, which is, if you were to balance the tether out on something, say, it's just like if you were to have a seesaw, where would that point be where it would stay stable? It wouldn't tilt anymore. That's the center of mass. Well, the center of mass needs to be close to geo, so that it can act like it's a geosynchronous satellite and stay put. So to do that, you actually either have to have more mass on the far end of the space elevator tether, or you can just have the tether keep going out further than geosynchronous, so that it will add up in weight.
So but it goes out into space. Would it stay in place out there as well? Would you have to how would you tether it down there?
That's the plan.
I love this.
It'd be a real expensive exercise if not. But the plan is, once the material's available, and that's the main technological surge that we're working on to make this happen, and which is the reason why we haven't really seriously thought about doing it in the past until we actually had a molecule that was discovered in the 1990s. But based on this molecule, if we make the material necessary for this space elevator cable, then what we most likely would do is get spools of it. The current design is about 3 spools, and launch that with conventional rockets into space, and then de-spool the tether down to Earth, sort of like fishing from space, and then lock it down, anchor it, and that would be your starting point.
It's great. It's fascinating. How did you become fascinated in this idea?
Oh, well, I've always been interested in space exploration, and I've always wanted to do it myself. But the astronaut corps is very small,
Yes.
highly selective, and so the chances of actually doing that, I could see just starting out as a high school student, was probably very small. But I was still interested in space transportation, space exploration, so I went into the field. And after 4 or 5 years of actually getting my aerospace engineering degree at UCLA, I've heard many different expansions, or they expounded upon many topics in terms of what you could do to get into space. And it wasn't until I heard about the space elevator that I heard something that might actually work and be cheap enough for many people to get into space in our lifetime.
Great. Well, I'll be watching for it. It is very interesting. And Jeremy, you tell me, how did you just finished doing a documentary, which you're just about to show to folks, and we're going to be able to look at a little bit of it, right?
Yes.
Yeah. All right.
2 minutes.
So tell me, just how did you become interested and excited enough to do a documentary, which is no mean feat?
Well, at first, my partner and I just went to the X Prize Cup located in Las Cruces, New Mexico, and kind of were exploring the whole excitement of the space elevator and the idea where they had the climber competitions where all these climbers are climbing up. You have thousands of people just staring up for no apparent reason until you look up and you're like, this is the advent of new technology and new travel. I mean, imagine the railroad tracks before they were built.
Yeah, and that concept of people saying, what, string iron across the United States? String iron? Two strands of iron? That sounds illogical.
And then the person who does it is the founder of Stanford, one of our
Absolutely.
local colleges here.
Good. So let's have a look at some of these clips, and we'll talk about them as soon as we come back from that.
Sounds good.
Okay, all right. Watch this.
Tether is a rope. It's sort of its application. The same thing with a tether attached to the earth. It's that motion using centripetal acceleration to actually, and centrifugal force, to actually draw the tether taut and fight the force of gravity that has always been exerted on it. The only thing that kept it from happening before is that it effectively has to carry all of the weight of the tether below it, and that's a long length. It needs to go out to about 60,000 miles.
Just gonna do one side.
Yes, you go first.
Confirm?
You always go first.
All right.
Done?
That's right.
Done.
It's not that hard, really.
Hey, last year I was the
phonetic.
only one not able to say it. Now everybody sort of picked up on it. Everybody devolved and are not able to pronounce it.
Maybe, well, everybody that I talked to, they seem to have it fun.
Team Astro Aeronea. Team Astro Aeronea, that should do it. And if anybody asks me if they said it correctly, I'll say that's perfect.
Fantastic. It's tiny snips of an hour-long documentary put together by Jeremy and his partners for your delectation tomorrow night, actually. Is that correct?
Yes, that's correct.
And where is that going to happen?
That'll be happening at the California Aerospace Museum. It's in
In McClellan, what used
McClellan.
to be McClellan Air Force Base.
Yeah.
And we'll be starting at 6:30. We'll be having food served. And we're going to have a brief lecture by myself on the actual topic of the space elevator.
Great.
We're going to have a lot of rocket scientists there and teachers and all sorts of folks. And then we'll have the film at around 7:30. and we haven't reached capacity yet, so we're still taking RSVPs.
Great, folks. So you do have to RSVP, and that's very important. But it's at McClellan, and it's tomorrow night at 6:30. If you've ever had that kind of, inkling to be around people who are firsters, people who are saying, I don't care if it doesn't, it's never been done before. We're going to try to do it, and that's what you guys are doing.
That's it exactly. Somebody has to do it.
Somebody has to do it.
On the edge of your seat and on the edge of science.
Yeah. I find it is a great thing to see these breakthroughs, and even we were talking about looking at the history of rocket science. We were talking about Professor Goddard in the early 20th century shooting small rockets and trying to understand rocket science. And
it's been around a long time now.
Yeah.
One of the founding fathers of rocketry is a Russian named Toskovsky. And a lot of folks don't know about him, but he actually established some of the founding equations for rocketry to prove that we could actually get into space, what was the speed that you needed to get up to get into space. And he even put forward the principles of using a hydrogen and oxygen rocket, which is what we use right now as our space shuttle.
wow.
And he did this back before the 20th century. And
Before the 20th century.
Before the 20th century in the woods right outside of Moscow.
Wow. Oh, well, we're out of time, but I want to thank you, Michael, and thank you, Jeremy, to come to talk to me about this. And I think it's a really special kind of thing that's happening, not only in your lives, but in America, and where science is reaching towards some aspects of understanding the universe and being able to reach in many ways towards the universe. And people who have dreams of traveling in outer space through your early life, you might get your chance, right?
I think so. I think this is a very exciting time in human history, and I'm glad to be here to be with it.
All right, well, good luck with you on your film. We'll talk to you guys later sometime. Come on back. It's good, and let me know how the film turned out.
We will. We'll give a great follow-up.
All right.
Definitely.
Good. All right. Well, we're going to take a short break here, and I have some very important messages for you. And we're going to be back, and we're going to talk to Ron Cooper about something about A Place Called Sacramento, which is a film series that's produced here in Sacramento. And then also we're going to have a wonderful musician, John Farias, who's going to play some great songs for us. So stay tuned for Live Wire.
My name's Brandon. 9 years old, being alcoholic.
Hi, Brandon.
I'll start drinking with the older kids. And whatever they do, I'll do.
Kids who drink before age 15 are 5 times more likely to have alcohol problems when they're adults. So start talking before they start drinking.
I know it'll start with alcohol. I'm just not sure how it's gonna end.
Drivers face all kinds of distractions.
Guys, stop playing now.
Before your wireless phone becomes one of them, stop. Drive safely. Keep your phone in easy reach and dial sensibly. In bad weather or traffic, call later and use a hands-free device. Remember, with wireless, safety is your call.
This is a man who almost learned to walk at a rehab center that almost got built by people who almost gave money. Almost gave. How good is almost giving? About as good as almost walking.